Hey YouTube, this is DIY Electronics, and today we're going to be going over a frequency generator using the 555 timer. In the last video I made about astable mode of the 555 timer, I'm going to show you how to change the schematic for the astable and turn it into a frequency generator to create a frequency that you can then use to power other projects or test projects. You can Google different applications for a frequency generator. This is going to be a square wave, and it's going to be adjustable. The max frequency that this can produce is 4.6 megahertz, and this is all in theory on what it can produce maximum, and lowest is 0.0001 or whatever, the smallest number, and anywhere in between there. We're going to be using this schematic for astable. We're going to modify it so we can then make our frequency generator. Typically R1 and R2 control the amount of time that the output is high, which is the top part of the square wave. R2 controls the amount of time that it's low. And by being able to adjust this, we can adjust the amount of high time and low time, or create our frequency, because 1 hertz is the amount of time between the beginning of the cycle and the end of the cycle. And we can either compress that or expand it to make it longer or shorter, and we can vary it with our trim pots. We're going to be using two 102 trim pots. They can either be blue or the ones that look something like that, with a little top on them, and they'll have a little number. 102 is the one we're going to be using, and what that means is that you add 2 zeros to the end of the 10, so that's going to be 1000. So these are both 1000 ohm trim pots. What we're going to do is take our schematic, and then we're going to take this out right here and put this in. So then we have our variable resistors for R1 and R2, and our 0.1 UF polarized electrolytic capacitor for C1. And I'm going to put the parts in the description in case you didn't catch that. We're going to be using a 0.01 UF ceramic disc capacitor, or on a ceramic it's 103. And a 555 timer to create this. I'm going to actually etch it onto a piece of it's a laminate copper clad sheeting I got. It's really thin. It's about as thin as paper, and you can cut it with scissors. So I'm going to try etching it, and to etch it I'm not going to actually print out anything and copy it on there, heat stamping or any of that. I'm just actually going to draw out my schematic and how I want it connected, and use a Sharpie to define my traces and try to etch it and see how that turns out. I'm going to pause the video real quick, and I'm going to go ahead and draw how I'm going to lay it out. And here's actually how I got it laid out on the breadboard. If you want a closer look. Alright. See you in a minute. Okay, after some head scratching, I came up with, you'll find out that whenever you're trying to put something on a board and actually figure out how you want it, it's a pain. But this is what I came out with, and it's all drawn by Sharpie, and it ain't no precision work, but I think it'll get done. And remember, you have to invert the image because it's going to be on the bottom. So when you flip it over and you put your IC on there, everything will be facing the right way, because if not, it'll be facing all different ways. So you need to kind of look at the bottom, then look at the top, and say, okay, my power's over here, my IC is pointing this way, so pin 1 will be on this side. So I flip it over, and you start using pin 1 as your reference and work your way around. I don't think I've seen anybody use Sharpie to make boards, but I'm going to try it, and I'm going to pause it again, and I'm going to go ahead and try to etch this, but I just wanted to show you before I etched it my horrible design. And I hope this is going to help somebody out. It's been a little bit of time. Hey YouTube, continuing this video about the frequency generator, I did some math, and after I finished etching my board, let me show you real quick. Yeah, it looks a little crude, but I can't get it to focus in. I mean, none of the connections are touching. I can't get that. It just looks like a big blob. But it's actually not touching each other, even though it looks like a big cluster. Anyways, the reason this wire is over here is because I thought I had misplaced a component on here when I drew it out, but I was wrong because I couldn't get the frequency to go down to what I wanted it to. And found out when I did my initial calculations, I had figured that I could go as low as I wanted since I had set it to a maximum that I wanted to reach. But after figuring out with the potentiometers I got, with 1000 max on R1 and R2, the lowest frequency would be 4,666, which is not visible. It'll just look like a solid light. And I can go ahead and show you that. That's what it looks like. My computer and monitor picks it up, but nothing else. It's adjustable. Everything works. Well, I wish I could get the camera to pick it up. Well, you can hear it in the background. If you can hear that, it's really high frequency. It's between 4,666 hertz and 4.6 million hertz or megahertz. So you got a broad range that you can play with, but it's not as low as I would like it to be. I mean, I would like minimum, between 10 hertz and 100 hertz. But that would be a low frequency generator, and I guess this is a high frequency generator. I don't know. I'm just playing around, and you guys get to watch me as I go. Yeah, I think that stuff does pretty good. I mean, this board, though, for being the fact that I only paid like $4 for like 18 sheets of this stuff, and to make that one, I used not even a 16th of the piece I had. I think it's pretty cool. And it only took me about 10-15 minutes to etch it and drill my holes and put everything on there. Yeah, I could do it a little better and maybe print out the thing, hot stamp it on there, but as thin as the stuff on it is, that'd be a pain in the butt. And I ran all my traces with a bead of solder just to make them a little bigger, because they're kind of thin, so. But, I mean, it works, and obviously it works. I just wish it worked to where I want it to work, but next time I'll put bigger potentiometers on there. If I wanted to, I could just desolder the potentiometers and put a bigger one in for each of them, and I could lower my frequency that way, or change the capacitor out to a bigger capacitor, and that'll lower my frequency. I mean, there's a lot of things I could do, but for now I'm just going to keep it like it is and play with high frequencies.